Uh, Good morning or afternoon. This is All Core Devs number 236. It's May 7th. Today we're going to talk about a little bit about the progress that came out of the Svalbard Interop. There is a blog.ethereum.org blog post on that if you want to catch up. We'll go over some other changes that came out of the progress or that are being proposed that came out of the progress. An AA update and an engine API schema fix. Do we want to start with Barnabas? You want to give an update on the Svalbard progress and some DevNet updates?
Sure. Can you guys hear me well?
Yep.
Yeah. So we started at Amsterdam DevNet 0 on the second day of in the interop. We basically included all the Ball DevNet 5 changes and EPPS. And then we basically went onwards from there. We quickly had some issues, and then we launched Amsterdam DevNet 1 just a day or two later. And in DevNet 2, that was 2 days after that, we also added a new EIP on the CL side. I'm just gonna put all the links here with the notes. So the new EIP was the EIP ACDE61, which is increasing the exit and consolidation churn limits. We also discussed to possibly DFI 8080 on the CL side. So we haven't made a explicit decision during the interop, but maybe this is something we can discuss next week on the ACDC call. Regarding any other CL changes, we decided not to push forward during the interop week on the forward compatible consensus data structures on the 7688, and we decided not to move forward with AD45 during the interop week, which is the exclude slash validators from proposing. Regarding the EL side, there has been a bunch of progress, especially AD37. There has been a lot of back and forth, and hopefully we can now have a finalized spec with finalized numbers. But I will probably pass the mic to someone that is more familiar with the AD37 changes. We have currently doc level access Bold 6 up and running with the old Lighthouse and Lodestar images. That has been quite stable. And we have Amsterdam DevNet 3, which is basically the same spec as Amsterdam DevNet 2. But we can actually keep an eye on it now. This morning I have started the P2P bids using Buildor, and it seems like Lighthouse was unable to stay at the head, and they seem to have some issues syncing at this point. That's the latest on Amsterdam DevNet 3.
Great. Thanks. Stefan, do you want to talk about Ball DevNet's progress during Svalbard?
Yeah, sure. So just a quick recap. We did some accounting change for 8037 that we went back on during Svalbard. And so we moved quickly from BalDevNet 4 up to BalDevNet 6. And BalDevNet 6 is going pretty well at the moment. But there are still some issues that were found. And I linked most of them in the agenda. So I will share a link here if someone wants to look in more detail. And then the idea is now to move to BalDevNet 7 with a new testing release, and that addresses most of the fixes that were found, and to also include the optimizations for the benchmarks so that we have one stable performant execution side branch. It's still called BalDevNet, but it includes all the EL changes, which is a little bit confusing. But then this should be the final BalDevNet, so EL side only branch before we only continue with Amsterdam DevNet branches. And there is one ask that Ben made, and I just summarized it here a little bit, is maybe we should have a debug get block receipts because the gas accounting is becoming more complicated with different variables, especially the split between regular and state gas. It would be very good for debugging to understand how much state and how much regular gas was used. This doesn't necessarily need to surface to the user, but it would be good to have something like this as a debug endpoint. And I just kind of um, created a recommendation of how it could look like. Maybe later, if clients want to speak on it or have some more specific suggestions, that would be great.
Sorry, could it also just be added to the receipt? Sorry. Like, can we somehow surface it? We could also just surface it in the block, no?
Um,
I mean, we could
Yeah.
do, but then it's a lot more field. But I mean, it might be helpful for users to work out where they spend all that gas.
I don't know. I think we should take this async somewhere to discuss it. I'm not sure where exactly the best place for it is yet, but I think it's something that we do need.
Okay, great. Stefan, can I just assume that you'll put that in the EL channel in R&D where people can go to discuss it?
Yes.
Great. Any other updates on DevNet, Svalbard, or like 8037? Maria?
Yeah, so I just wanted to clarify something quickly. So we are working on Ball DevNet 7 for next week. But at this point, we still have some clients working on some optimizations, and those should still be merged to Ball DevNet 3. So we are working on Ball DevNet 7 with the fixes from 8037, and that should then at some point next week become our EL stable branch. But until then, for the clients that are working on the optimization still from last week, please merge them to Ball DevNet 3 so we can see the results on benchmark. Sorry, I think I may have missed some of the numbers there, but essentially it's like merge optimizations to Ball DevNet 3 until we have Ball DevNet 7 stable.
Great, thanks. All right, any DevNet, Svalbard, 8037? Otherwise, we'll move on. Okay, so in that vein, just like some process, we had talked about an SSI definition change at Svalbard. At one of the sessions, I had brought this up on a call about a month ago to look through this SFI definition. I have made the final changes reflected that discussion. If there are no objections, I'll move to get that merged in the next day or two. And then based on that definition, I think that Dan Ceratops had a list of EIPs that could be moved from CFI to SFI that would help both ecosystem participants know that these are the EIPs that are most likely to go in. They're being worked on. They're quite stable. There's like a set of 4 criteria in that SFI definition. And he did a draft proposal or draft PR to move those to SFI in 773. So if there are any objections to that, please comment on that PR. Otherwise, we'll get that merged by the end of this week. Tony?
Yeah, regarding the process, I mean, I brought it up in the Svalbard session. The only thing we should think about is how do we then decide what to put on DevNets and what not. because this is one of the criterias in that in those 4 points, and we don't really have a process for that right now.
Yes, I think that you may have missed earlier this year. We did actually make a prioritization list for the CFIs that are in Glamsterdam. We didn't like put it anywhere. We just discussed it on a call once, and I think 8037 was number 1 on that list. I will make sure
It's
to
on
post that.
forecast, right? I mean, I know
It
that
is
I
not
I
on
know the
forecast.
prioritization. Okay, but there was a prioritization with the tiers on forecast, and we didn't really go with the order we had on forecast. We were randomly like choosing EIPs that we put on the DevNet. For example, 8047 was like the second lowest prioritized EIP by clients, but we still agreed it's like important. So I think we should either not overcomplicate things and just keep the freedom there and put things on a DevNet that we think when we think it's the right time. Yeah, I don't think we should directly go by the prior list.
So the prioritization list that is not on forecast. I will link it somewhere. But we can. I think we're not going to have to CFI or like prioritize a CFI list again until we get to the final list for Hagoda, so we can discuss if this is still like a controversial move. But I think it does help the testing teams decide what goes in, and the criteria listed there was that basically the facilitators work with the testing team to create that prioritization list, propose it on all core devs, make any changes the clients think are more appropriate, and then that's quite a flexible list. So that's just reflecting what the clients think. The ordering should be what's based on what can go in, what's able to be implemented, what's important to implement, not just what's easiest, not just what's most desired, and then put that in the meta. And I think the idea is that's flexible. That's not like a rule set. If things change later on, then we can move things up and down that prioritization list, but it just helps the testing teams figure out what should go in. And I think that we can bring that up at ACDE if anybody thinks that an EIP is misplaced on that list. Pooja?
While we are addressing the PR 11475, which talks about the specific condition, I would like to request to kindly look into the PR 11006, which actually talks about an important part of this proposal 7723. So basically there is a difference between EIP status and EIP stages. So I believe that it has not been correctly documented in the proposal, and the PR suggests that we should actually update statuses with stages wherever applicable, wherever it is related to network upgrade, not the EIP standardization process. So just wanted to bring it to attention.
Okay, great. That is in the chat. If you have any preferences on that wording, please go comment on that PR. If no objections, then we'll move to SFI those EAPs. Most of those are in, I think all of them are in DevNets. There was a comment that 8037 is not. But the argument for that was the amount of work that has been done during Amsterdam and the fact that it is very unlikely to be.
He meant 8038.
Oh,
8038 is not on the DevNet, and it shouldn't be SFI'd at this point, but 8037 is.
Okay, yeah. 8037, 8038 is not on that list.
Yeah, I off by 1 hour.
Okay. Okay, we'll move on to 8070 changes. Camille, are you here?
Yep, I'm here. Yeah, just want to quickly highlight changes to 8070. We had a good progress in Svalbard, discussing sparse blog posts. So we merged already the changes required in engine API, basically introducing GitLab 3.4 and some updates for fork choice updated calls. So the last piece remaining is make some final changes to 8070 EAP to kind of nail down the behavior for the builder, and also just highlight this engine API changes. So please take a look. Yes, I believe Geth team is actively working already on the EAP, and Nethermind and Besu also kind of either working or considering to start working on that soon. So as soon as it's implemented in more clients, we can schedule for the upcoming DevNets. So please take a look. Thanks.
Great, thanks. Tony, do you want to talk about clarifying the min reorg depth without resyncing?
Yeah, this was one of the points we discussed at Interrupt 2. Basically, how far do we want EL clients to reorg back in case of a deep reorg without triggering resync? And I think some clients like Geth are prepared to reorg back quite many blocks, whereas other clients can only reorg back like a few epochs. And it would be great if we can align on a number there. And there have been multiple numbers proposed. For example, the 128 blocks, which was the minimum there. Then there was the week subjectivity period, so about 15 to 16 days. I think Jacek also proposed to have it more like 38 days, which is with the inactivity leak kicking in, the amount of time we need to restore finality when 70% of the network are offline. So we don't need to resolve that today in the call, but it would be great if people can look into this agenda item and we can resolve this and have EOS align on that number.
Is there a deadline by which we sort of need to have that sorted?
So in theory, we should have sorted it today, I would say, because reorgs could have many time, and I think many clients would today just trigger sync. I think Geth is basically ready because Marius was at some point saying Geth can reorg back like 90K blocks or something. That would be roughly the week subjectivity period. I would just ask other clients to look into this and then figure out like what to best do in order to not fall back into SnapSync. I know that sometimes it might take a while to restore the old state by going through the state lifts and apply them, but this might be better than just returning an error to the CO. So better we miss a few blocks than we fall back into SnapSync.
Karim? Karim, did you raise your hand? Yeah, okay.
No, I said we have a PR in Bezo for that, but as I said, it will be nice to really have a test with a shadow fork, even if it's not something we will run a long time, just to see the behavior of the different client in a real environment with a really good test close to the reality. Because we have a PR today, but it's difficult. We can do a big rollback, but we need also to check after the rollback to roll forward with the new head and see how the client will work correctly with the CL, etc. So I think it will be nice to have a test to verify that we are working correctly in this case. And maybe it will help to define the right amount of block. Like that, if we have a test, we can try different reorg size and decide what is the best.
I'm going to call on POTUS before Felix because POTUS couldn't raise his hand before.
Oh, yeah, I just want to make a quick comment on the issue of reorging back. I think
So this is a problem that happens on EPBS, that we might send an FCU to a previous chain on the EL side. But I think you guys should read this post that I posted on the chat. I think we should avoid completely, and we should even probably forbid an FCU to without payload attributes to roll back. That means these reorgs bags are only relevant to building the next block. They're not relevant for the user that is following the chain, and it's not really relevant for the CL client to send an FCU without payload attributes to go back in the chain. So I think this shouldn't really affect users. We should never try to roll back the chain live on regular sync. This should be only used by the proposer of the next block to trigger block production. So only builders and proposers should use this rollback, and no one else.
But Putus, that means we would need to have this reorg within the proposing window within the 12 seconds, right? And this is not possible.
Yes. So what will happen is that the proposer will find out at the later in the slot that his head has just rolled back, and it will only roll back by one block. Actually, it can roll back in the event of an attack, of a majority attack. It can roll back up to the justified checkpoint and not more than that. But if there's no one that has a majority of the stake that is malicious, we can only roll back one block. And it's only for the proposer to say, you need to build me a block reorging the last payload.
I have a question, Boris. You were saying a bit different stuff before when we were discussing this change. So I don't
What
know
is
if
the thing that I said differently?
Oh, I mean, like that. Now you're saying that basically we don't need to do revert on the same. I mean, like reorging on the same chain deeply back, even if we are syncing, right?
Well,
yeah, but before that, you were kind of like saying that we need this revert up to a finalized checkpoint. I'm just wondering if anything has changed in that time.
Nothing. The spec is the spec. So formally, we can have a reorg. Nothing is finalized. No payload is finalized until it's actually finalized. So we can, in theory, you can always reorg back all payloads. In practice, the proposer is the only one that should trigger this, and the proposer in practice, and even in theory for the proposer, can only reorg back up to justified, because no proposer would reorg its own justified checkpoint. So that's one thing. And the other thing is that if you're not under, the only way of reorging more than one block is if there's a malicious majority.
Felix?
Yeah. Are you still talking about reorgs within the canonical chain, or are you talking about?
Yeah, it's only within the canonical chain. But the post that I want you guys to read is that the important thing about this is it's that the user should never see this. So but a user that is following the chain should never see a reorg back on the EL. Only the proposer should see such a reorg back.
Yes, but
talking a little bit about something else, yeah.
Yeah, we're talking about any reorg, not in the canonical chain.
Oh, yeah, that's a different story. That should be up to finalize in theory.
Yeah, so we are, what I wanted to just give a quick overview, maybe this topic can also be settled later. So there is an EIP proposed. I'm not sure, I think Tony, you proposed it, that basically clarifies the expected reorg window that clients have to support. And I think that is a good direction to go in, because in the past we have just completely left it up to the client. And this has led to the situation where there are some clients that cannot reorg very far and others that can reorg very far. So in Get, we always had this opinion that we have to be able to support very long reorgs in case the chain will actually hit this. However, it is important to consider that a very long reorg in the chain would also have a significant user disruption. Like regardless, if this happens, the chain is going to be under heavy attack. Still, it is good to clarify it because in case of such an attack, we have to be able to recover quickly. And the only way to do that is if the clients don't fall into the snap sync. Because in the case of a syncing chain, of a chain being attacked, the snap sync efficiency will also degrade. So we have seen this in the past with testnet incidents where even getting clients to sync is the main issue. So what we would ask is that clients extend their reorg window, and this EIP does it. However, just as a quick comment also about how Geth handles this, it's not actually required for clients to have the state like all the way back. That would make them an archive node, and that's not really the goal of requiring this. And it's also not said that reorging back the chain like many blocks has to be a particularly fast operation. It doesn't have to be instant. It's just that it has to be supported at all. So I think one thing is we should really start to create some test that exercises this and also see how the clients behave, just so that they have this theoretical capability. And then we can just see where it goes from there, like what we can all agree on. But this like 38 days period or something sounds pretty reasonable to me, because if there's a natural limit in the beacon chain for how far back it could theoretically reorg at all, we could just use that limit and that should be fine.
Marius, is your hand still up? Okay, POTUS.
Just from the engineering perspective, I'm a little bit confused. Wouldn't this in the happy case be a no change? Like if you're finalizing, then it should be fine. You should be able to reorg the last 64 blocks or whatever. And if we are not finalizing, only in that situation you trigger being sort of like an archive node since that point.
It's not about being archive node. This is just about the client being able to walk the chain back to an earlier state. In Geth, this is achieved by storing reverse diffs of the state up to a certain depth. And we need those reverse diffs just to be able to walk the chain back in the theoretical case. It's not fast to do this. But
yeah,
then,
no, I understand. But my point is that you don't even need to store anything if you're finalizing. You never need to reorg back if you're finalizing.
Yeah, this is kind of true. We could, in theory, truncate also these reverse diffs to the finalization point. That's correct. So if we are certain that like there will never ever be a situation where we have to reset back to a point before finalized, then yes, in theory you can delete everything before the finalized. But you have to be prepared in the client for a situation where finalization is not working.
Great. Do we want to take this off sync or offline and discuss it maybe in that EIP PR?
It would be good to get more statements from clients. I mean, the execution clients are all here, so and you guys should all know like what are the limits of reorg. So just to hear it from people, what's the situation? What do you think about it? It's not a slow. You can just have a quick round of statements.
So
Lukasz?
we are working on supporting reorg up to finalization barrier to make it dynamic, and that's our goal. And it will be then arbitrarily long as where the finalization barrier is.
In Bezo, we have something similar to Get. We have the trilog with the prior version of each content slot and the new value. So we just have to apply this trilog to roll back. And we already have a pruning mechanism that is not removing trilog before finalization. So as soon as we have a finalization, we can start pruning the old trilog. But before that, we are keeping this trilog. We just have to modify the logic to not have out of memory if we have a deep relog, and we have a PR for that. But thanks to that, we should not have any really limitation. Can choose a big number, it will not be a problem, I think. But we need to test. I think it just if you have a test, we'll be more confident.
In Aragon, the default is that we can only unwind to 512 blocks. So we probably need to make some changes to support extremely long reorgs.
Do we have anyone
ju-
from Ref? Go ahead, Kareem.
I just wanted to say something. In Bezo, in order to manage the deep reorg, what we are doing is to do this rollback by batch. So we are applying an amount of try log. We are persisting this state and restart applying a batch of try log, etc. Like that, we can remove the issue of out of memory if we have a really big reorg.
From the Ref side, we couldn't handle the 1 month at the moment. We need to make some changes. Are those blocking changes? I think it would just be a bit of work for us. So it depends on like when you need it. But yeah, it would be super slow for us, like Felix is saying from Gap.
Yeah, so can we do, my feeling is that clients are all more or less ready for that until Amsterdam. So I think as of Amsterdam, we can assume that EL clients will be able to reorg back the 38 days, which is the number that Jacek proposed, which is the inactivity leak with 70% of the nodes being offline and then restoring finality. And then I would update the EAP. Currently, it has the week subjectivity period in it, and I would update it to the, I think it was roughly 38 days that we would then have to reorg back at the maximum.
Is there any other client besides Ref who doesn't feel like this is currently doable?
Well, it's probably doable, but as I said for Aragon, we have to make some changes and to do the testing. So right now, probably doesn't work out of the box. It's everything is doable, but it seems that we have a lot of things required for Glamsterdam. We try to do it, of course, but like let's not repeat our mistakes with Spectra when we had to split it into two forks.
Yeah, I agree. This doesn't even need a hard fork, in my opinion. Like, this is something we should just agree that we want to move towards to, but this is nothing that can break consensus here. So we don't necessarily need to do it with Amsterdam. But yeah, we can just say, okay, we agree that we want to get there as fast as possible. And if we have it at Amsterdam, great. And if we don't, then sometime after Amsterdam.
Yeah, I think that's reasonable from Ref's side. Joachim?
Yeah, I wanted to quickly ask, because I saw that in Hive this is possible to test, but since this is like a very deep reorg, is this directly supported? Because I would like to help testing this, and also because this is mainly about the performance, but this is also part of like a benchmark or whatever. But I think this is like very handy to see what the impact is on these kind of attacks.
Otis?
Am I correct that the danger here is that if I receive such a block and everyone that becomes, I send new payload, I get an accepted because they verified the block hash, and then for some reason it becomes my head, then every client that cannot actually execute that reorg becomes optimistic. So in principle, we could just immediately stall the chain if every CL says this is the head and we're all optimistic. Is that the case?
It depends on what status the EL will return in the response to that reorg.
but I haven't triggered the reorg yet. I just sent new payload, and it's based on a very, very old guy. So I assume that the EL does not execute it. It just tells me syncing or accepted, whatever was the original one. And then I can actually just send an FCU to it. If the EL has not finished executing, it will tell me syncing. I will just change my head to that, and then suddenly we're all dead because we're optimistic, all of us. That's my reading of what you guys are telling me happens. I mean, in that case, I don't care that it's too slow. It could take like 6 hours, but as long as the block is actually executed, we don't lose liveness.
Yeah, like for gas, it is being executed. It just takes a long time, and we can only do 90,000 blocks instead of 120,000 blocks. So we like, for us, it's just a parameter change, but other clients don't have that capability yet at all.
But if so, you have to execute a block, but before that, you have to obtain the state, right? Which is kind of like 100,000 blocks ago. I mean, like it diverges from the state that you have 100,000 blocks ago. So you have to apply reverse diffs and then execute a block. Is that correct?
Yes, exactly.
So, and I saw in the chat that it will take about 6 hours, right?
I think so. But like we have to also test that.
All right, and yeah, I see. So in which status will be responded in the engine API in this case? If it's going to be like syncing, then it becomes the head. What Boris is saying, then all CL nodes that got into this situation will be optimistic.
If I understand Sina correctly, we don't return anything. We just do the reorg, and then at some point we return accepted or valid.
But I think on new payload, you should return immediately without executing.
Yeah, on new no, this is on Proxys updated. This is only if you really force us to execute this block. On new payload, we can just ignore it. This can only happen in the case where the CL node says this is our current block, and that can only happen if there's either non-finality going on or a majority is malicious.
Then can I suggest that we agree on, if we are in such a situation, we decide that all clients should either return syncing or all clients should execute and not return anything? So not to have a split there. If everyone returns syncing, then we all become optimistic, and then we wait until someone can actually execute it. And if everyone doesn't return anything, then the reorg is not even performed, because we do not change head until the EL tells us. We actually time out, and we would consider that block as not imported.
Okay. Do we have any other open questions around this? Because I feel like we maybe aren't going to get to the option that we want to choose today, but we have agreed that testing is needed, and it sounds like Joachim and Mario can work on testing. Okay.
Yeah, and maybe apart from that, it would be great if, I mean, Jacek already looked into that. I looked into the number today a bit too, but if we can That might work async if we get more confirmation that those 38 days might actually be the right number there.
Great. And the
I will
best way.
update the EAP right after the call, and then I can drop it into the CL chat.
Perfect. Okay. We're gonna move on to 8254. This I think was a Barnabas and Marius topic. Do you guys, or do either of you guys want to talk about it?
Yeah, so the main concern came from the initiative to raise the gas limit in Amsterdam to 200 million gas, which will basically allow us to exceed the 8,192 deposits in a single slot transaction, which will basically make all the CLs fail. There's a few ways to get around this. One of them is get rid of the limit. The other one is to enforce the limit on the EL side, and yeah, we could just also increase the limit or decrease the limit. This is basically what we should discuss.
So to be clear, this would be a new EIP in Glamsterdam in order to enable.
Yeah.
Okay.
Yeah. So the A254, the one that Barnabas is proposing, basically says that we have to count every deposit, and if we are above.
In Lichtenberg. Hmm?
Sorry?
Go ahead, Marius. Yeah. I think that was an accident.
Oh, okay. We have to count every deposit, and then after every transactions we have to check whether this transaction can still fit in, or if it can't, and then we have to move it out, and then so yeah, it makes block building quite a bit harder. For block verification, we can choose to either verify the limit after every transactions, or we can verify the limit after the end of the block. Verifying it after every transaction has the advantage that we can error out earlier. Verifying it at the end of the block means we will, in the worst case, spend more time, but it's much easier to implement. Yeah, I'm not a big fan. I had the idea of just deleting every deposit that goes over a certain number, and just but that is griefable. Another idea, and it has gained some laughs in the chat, but it's actually a serious idea, would be to switch out the deposit contract with a different deposit contract that codes a limit per block, and then we would actually limit it where it makes sense, because right now the idea is to limit it in the single part where it doesn't make sense, and that is the EL. It would make sense to either limit it on the deposit contract or to limit it in the CL. Yeah.
How would you propose to limit it on the CL?
I can give a comment. Sorry for earlier audio issue. So we can either reject the block on the CL by just validating that there are not more than X number of requests. However, this is a bit awkward because it creates a new invalidity condition for the block on the CL side only. So it's kind of like basically we would have to modify the fork choice to say that this block will never be, in the active fork. So this is possible. Or I was also wondering what it would take to raise the limit on CL side.
We'd also need to change not the validation rules, but the building rules so that it doesn't, the CLs don't reject the block, it moves to another EL, which overstuffs the deposits, which then gets rejected, which moves to another EL, which then overstuffs the deposits. Otherwise, we'd halt by just doing the same thing again and again.
Tony.
Yeah, I agree that this makes block building a little bit more complicated because you would basically introduce a new knapsack problem where one transaction could basically consume, for example, all 512 deposits, and then you can't really append more transactions into the block. So we basically, in addition to the gas limit, we would have another very arbitrary limit that you can't even statically see like we do for block transactions, for example. There we have the same problem, but we can at least statically see it from looking at the transaction, which is not the case here. But yeah, it feels like Barnabas EIP is the simplest thing to do, but just capping it, and the EL client would just abort block building or not append any more transactions if we hit it. Just for context, this almost never happened in the past. So I think we had 2 blocks that actually went over the 512. So this is really an edge case we're talking about here. So I would prefer a very simple solution here.
Marius?
Yeah, quick question. Puto seems to be worried about builder deposits. I have no idea how they work and whether they will run into the same problem. So it would be, are they also deposited via the deposit contract?
Yes.
I
Can
can
we
comment on that. So from the perspective of the EL, they're just the same. They're normal deposits. So for block building, I guess you're not going to recognize this. But the problem is that on the CL, we might actually need to do signature verification immediately on the block as we are importing it, which is not something that we do for normal deposits, for validators. So this, in that sense, what Tony said, which is right, we only had like one of few blocks with this many deposits, like 512 would be more than fine. My fear is that for builder deposits, we do not know if we can actually survive 512 deposits as we did for validators, because for those validators, we didn't need to immediately verify signatures. We put them in a queue, and then later on, on a churn, we verify those signatures. For builders, we would need to do this on demand immediately, which I'm not sure we can handle. And second, we do expect at the fork boundary to get a lot of deposits for builders. So I would not discount this problem of builder deposits. So if there is a word in which we can cap this, the building time on the EL, that would be great.
Okay, great. Do we want to do, is there any opposition to PFIing that to 7773? And then
Can I
it sounds like
ask,
sorry?
yeah, can I just clarify? It would seem to me that if you do this, there's a denial of service attack where people you send a transaction that spends loads of gas, and then after spending that gas, turns out to not be includable because it makes a ridiculous number of deposits. So I'm like,
Yes.
I'm quite wary of doing this. I'm like, could we not like find a way? Basically, because currently we have a rule that you can tell cheaply and statically whether a transaction is includable. And once you pass that check, you can include the transaction in the block. I'm very skeptical that it would be a good idea to add a condition for block validity that violates that principle. So we should, the transaction should fail in some way and still be includable if it busts this cap. Just getting to the end of the transaction and go, oh, sorry, you couldn't include that, doesn't like align with the basic principles that the EL goes with.
Tony?
Yeah, what Peter is saying is true. So basically, this is exactly the problem that, and what Marius was proposing would fix it. Basically, switch out the deposit contract, because then we would essentially have the transaction revert in case the maximum deposit number is reached. Otherwise, EL clients would have to find a way, for example, just abort block production at some point if they keep trying to append transactions to the payload and the block turns invalid because the maximum deposits is reached.
Felix?
I just want to give the quick note that we already have such a condition in the form of the maximum block size. So even currently, the builder has to be aware of, so the builder has to be aware of like how big is the block that it's currently building. But it's a bit, it's like kind of goes in this direction also. But so we do have to verify that condition while building.
Okay, just to sort of time box this, do I understand that this is like the biggest blocker right now towards 200 million gas for Glamsterdam?
Yeah, we could safely do 190, but as soon as we go over 193, we are gonna have issues.
Marius, if your alternative direction, would that be a different EIP or would that be 8254? What would be changes to 8254?
So the problem, well, it seems like even 190 is too much because CLs cannot handle more than 512 or more than a couple of builder signatures. So I don't know.
Can we propose 8294 to Glamsterdam and have this open as a way to address this one last blocker, and have people discuss this async about how to fix this one last blocker to 200 million? Felix?
Sorry, I should have
Okay.
lowered my head.
Okay. Okay, I will Barnabas, if you want to PFI 8254 to 7773, and we'll have it in the PFI and not CFI, just to indicate that there are open questions that need to be addressed, because we would definitely like to get that floor of 200 million, if possible. Right. Let's move on to Pavel has two items related to self-destruct, one Glamsterdam related, and I think one general. Pavel, do you want to take the mic?
Yes, hello. So I'll start with EIP 8246, which proposes to remove the burn feature of self-destruct. So not going into like very much into details, the self-destruct has like multiple things it does at the end, but it can also burn if you target the if transfer to yourself, and the main motivation why we would like to remove that is the other EIP 7708, which emits logs for transfers and also emits logs for burn events. So kind of contrary to this EIP, I propose that instead of emitting logs for the burn events, we actually get rid of burn events from EVM. And that's like the main motivation of this EIP. How this is done is basically we try to persist the balance of the account. So distraction might not be like complete in the end. We might be left with the accounts that will be empty, but will have some balance left. yeah, so that's basically like rough overview of the CAP, and proposing this rightfully triggered the question if we can completely remove self-destruct. And I think it should be clarified what the complete removal means. It's not like the self-destruct instruction will stop working. It will still do some stuff, but in the limited factor. So I think the agreement is that it will behave as sometimes called send all instruction. So we'll still send if to the targeted address, and will terminate the execution of a call at this point, as it does currently. And this has been proposed previously, and we kind of went back to some defensive positions, and we removed self-destruct partly, but still in the case an account is created in the same transaction, self-destruct kind of behaves as historically was designed. Okay, so yeah, that's basically like intro to this part, and I collected some data about self-destruct usage in the current mainnet, and I can give some details, but basically this is available already. So I can send the link to the AP, the first unmentioned, and my like brief report about self-destruct usage. And if there are no questions so far, I can go over like basic, like some overview of the data I collected. Okay, so guess no questions so far. So I collected all the self-destruct events since for the last 5 million blocks, and this like yeah, the block 20 million happened right after Cancun, so this was the point where we modified self-destruct already. So we have all the events that happened in these 5 million blocks. And the usage of the self-destruct actually increases, although the deprecation notice that we kind of notified users of previously. So absolute values go up. If we compare that with the gas limit, I can say roughly it stays on the same level. So we might want to attribute the increase of usage to the gas limit increase, although we can also identify like more unique users coming for this pattern. So that's one thing. In general, those like this was 500,000 events that happened within these 5 million blocks. And if we consider like the context where self-destruct is completely removed, that would cause creation of additional 400,000 accounts. Some of them would have some code, and the code is actually very small. This all combines into around 3 megabytes of additional code. So the number of accounts are quite big, I would say. The number of code is like tiny. And why people use it, I'm not currently sure. I try to classify this, categorize the usage, and I have some idea how to do it, but well, there's not so much time to do so far. And finally, so the gas schedule. So the users already pay for the creation of their account, and they don't get any refund coming from the self-destruct. So like this, not from our perspective as a kind of protocol devs, this not really issue. So even if the account will remain in the state, someone paid for them. And within these events of self-destruct, like majority of these would work as it is right now. So basically the only difference would be that there was some dust accounts remaining after transactions, but the workflow will not be broken. So only 12% of this usage would be broken, and this only happens with if any of these schemes reuse the same address, because the next time you want to create account on the address and it wasn't, and if it's not properly self-destructed, it means the creation will fail. This is 12% of all of these events, but still, I think this is the part we'll need to like dig into. And yeah, so basically that's the overview. My personal comment is that from the usage patterns, I kind of find some like elegance into this, that they actually clear after themselves. Because many of these usage is basically like create like a top level account, do some scripting, and then self-destruct. There are definitely other ways to do so, but yeah, this is kind of like, at least it doesn't cause unnecessary state decrease in this region. I mean, yeah, so that's it. And I think that's all from me for now.
Peter?
Yeah, firstly, thank you. That's incredibly helpful, and I really appreciate that you've gone to the effort of producing this data that we can look at. I basically agree with you about the whole wasted account. We currently charge people for creating accounts that get self-destructed in the same transaction, and then we don't refund them that if the account gets self-destructed. We don't care if such accounts end up in the state because they've paid for them. I find the fact that you've located 60,000 transactions in 2 years that would fail if we removed self-destruct makes me skeptical that we'd be persuaded to do it. Like, I think I agree, everyone agrees that if we could just get rid of self-destruct, we would absolutely like to do this. But the only reason we kept self-destruct is because users told us that it would break stuff if we removed it entirely, and that this was basically the only use case. And we've historically observed a very extreme policy on changing things that might break current users. And there are a lot of candidates for things that we would remove if we were happy to like break the occasional user. So I just don't see how it's viable to remove same transaction self-destruct, given that there are 30,000 cases a year of people actively relying on it, as in their contracts and transactions would break if they didn't use it, which is my understanding from your statistics.
Yeah, I wanted to raise my hand, but I lost where the button is. But anyway, yeah. So like I have two comments. One, all of this data is available if someone wants to do like further analysis or anything like that. Secondly, I think this situation is not so dramatic as it sounds. That's my observation, although I don't feel as an expert on like usage analysis of contract. So many of these usage are still kind of scripts. So you kind of make a decision to send it and the moment you create a transaction. And the other part of the usage is some kind of like operation, like operator doing some stuff with a factory. But this operator kind of can be identified as a EOA. So it's actually also like kind of decides to use a contract that has this pattern in there and the moment it sends the transaction. So I think there's a way to migrate that. It's not like a yeah. So I kind of find it this pattern is basically some like helper EVM bytecode, but I kind of feel there's a way to migrate existing users. How to notify them, how to identify them. It's kind of I don't know, but if you if you go deeper into data and like the usage patterns, I think we can identify some ways. But yeah, kind of agree also that we would need to at least make sure we actually find all of the cases that we need to handle.
Okay, Paul, is it accurate to say that 8246 is being proposed for Glamsterdam to enable 7708, and then the removing self-destruct is a longer term goal that might be for Hagota, and maybe needs a little bit more analysis into whether
yeah, I think that's not accurate. Because we also had discussion with the testing team, and I think if you want to completely remove self-destruct, I think the moment of Amsterdam is also a good one because it simplifies other APIs to my understanding. But maybe someone from the testing can comment on this.
I think that the evidence, having looked at the data for these two AIPs that you've produced, is that removing the self-destruct burn is at the level where it's unlikely to create any real breakage, and it is somewhat annoying. So I would be quite supportive of that. Like removing self-destruct entirely, given that it has actual users who will experience at least some breakage, is going to require like long-term research and definitely can't make it into Glamsterdam.
Mario.
Yeah, I can comment quickly on the testing. Yeah, definitely will be nice, but I feel like if UX is gonna break in to some degree with this change, it's I mean the nice part would be that local access list and 8037 would never have to interact with self-destruct. That's very nice because we will remove a lot of cases where this is like a problem to testing, but we have already like test cases for that, so we're not really removing work from us. It's like basically we're just simplifying the change, which is good. But I feel like, I mean, yeah, I do agree with the point that is maybe too short notice. So for us, I feel I'm leaning towards the burn removal. I think it's a nice middle point.
It seems like there's some support for that based on the emoji reacts in the chat. Powell, does that sound good? And if yes, do you want to do a PR to CFI that in 82 in 77?
Yeah, sure, can do that.
Is there any opposition to going straight to CFI for that EIP, given that it seems to have broad support? Great. If not, we'll move on to Hagota. Okay, we have a couple proposals for Hagota and an AA update from my client. Do we want to start off with 7709 from Ignacio?
Yeah, sure. I have 3 slides to present this, so should be pretty quick. Give me a second. Can you see my screen?
Yep.
Cool. Yeah, so I wanted to propose 7709 for Hegota. And as a TLDR of what this EAP is proposing, today an EL node, whenever it has to execute a block hash opcode, it resolves the result by using an in-memory cache of the last 256 block hashes. and that's justified by the current price of block hash, which is 20 gas. And what the EIP is proposing is that at the protocol level, we decide to resolve block hash values via an S-load against the system contract of EIP 2935 that was activated in Prague. Because the system contract is storing the history of the more than 8,000 block hashes. So since block hash in window size is the last 256 values, this can be resolved from the storage tray of the system contract. So the reason why I'm proposing this is that block hash not being resolved from this system contract creates some complications for creating the execution witness for stateless environments. So if you're trying to execute a block statelessly, and this block contains a block hash execution opcode at any point in the transaction list, the stateless client should receive this value and approve that this value is correct. So since block hash is a kind of stateful opcode that is not really being resolved from the tries, this creates some complications whenever this execution witness is constructed in a stateful EL, because for other stateful opcodes like S-load or balance, the EL state tracker usually will be aware of this access happening. So creating an MPT proof for that stateful access is pretty natural, but for block hash, it's not really the case. And the execution witness construction needs like an exceptional path to really resolve this because it's not like formally a state access. So that's basically the gist of the motivation for this. So it's basically making block hash not be like an exception compared to other opcodes that are stateful. The kind of main concern that this EIP can have is what is the UX impact, because making block hash be resolved via an S-load to a system contract basically means that we have to reprice it to be aligned with what is happening. So that means that we will be moving to the current 20 gas price to an S-load cost. So it might be cold or warm, depending if the block hash is repeated or not. So that's a decent amount of price change. Like in the worst case, it will be around like a lot of change for users. And actually, if EIP 8038 happens, this will be even more than today. The final numbers of these EIPs are not really yet decided, but probably we will expect a big change. So yeah, this might make things worse. So I'm planning to run a replay analysis of historic blocks to really understand which is the UX impact. Probably I will try to wait until 8038 has some finalish numbers, and we can try to understand which is the UX impact. I wrote some deeper analysis around this EIP, some implications. So here's the link if anyone is interested. I also write the specs and tests in the execution specs repo. So yeah, I will share the slides, the link to these slides in the chat so anyone can look at them. And yeah, that's mainly it.
Felix?
Yeah, sorry, I just have the quick question. So is it you are giving the main motivation for this change that the stateless client would have to be aware of the hash, but is it not reasonable to expect that the stateless client should be aware of the last 256 block hashes in the history? I feel like this is a very obvious, I mean, most stateless clients will be aware of it. You would really have to have a client that is like completely unaware of the chain in order to not have this.
Right. So the idea here is that the stateless client doesn't really need like memory about the previous blocks that were executed. So I want like the execution witness to be self-contained regarding what is needed to execute the block. Because if not, you need an execution witness plus some kind of memory of the last blocks that happened.
Yes, I understand this. I was just wondering, like, what kind of client would that be? Because like I said, most clients that are participating in the chain at all, even very, very lightweight ones, would have knowledge of the chain. I'm just like really wondering, like, I feel like a very narrow case for a client. I mean, there's more like a philosophical change, I guess, that you're trying to make.
Yeah, I think this is mainly about just making the execution witness just have all the information that is needed for executing the block statelessly. It's just basically that, and not having assumptions about these stateless clients having knowledge about what happened like previously. So it's like a pure function stateless client.
Oh,
Yeah, so I think this is not like super fancy change, but it makes the witness very much consistent and self-contained. For example, you can pin this this element in the storage to the block hash root, block state hash root, right? Otherwise, you would need to have like the hash chain of blocks to prove the values are correct. And for that, you would need to block headers to actually hash them and so on. So yeah, there's nothing we cannot do right now, but it just makes it nicer. And then like the witness is only about state, there's nothing like external elements there.
Peter, and then I'm going to time box this so we have enough time for the last 3 items on the agenda.
Yeah, that makes sense. I was just quickly going to say this is a very small change, but the benefits really are quite substantial. If we get rid of this, we're pretty much going to be in a position where you can validate a block with only the current block and its body, the parent header, and the state. And currently, you require the last 512 headers, and there's no good reason for this. Now we have this contract, so this is a very sensible change.
Great. Let's move on to EIP 8253. Joachim, do you want to take the mic?
Yes. Let me also share my screen. Okay, I also have some slides. Can you see my screen?
Yep.
Okay, cool. So this is about, I will speedrun this one. So let's go. This is about EIP 8253, remove PSP Dragon accounts. And the context of this is also about EIP 7610, an EIP by Gary and Martin, which I've PFI'd for Glamsterdam. It is still in PFI because this is somewhat, I would not say controversial, but okay, let's get into those points in a later slide. So if we go back in time at 9.5 years ago, at change start, we could create contracts which did not start with nonce 0, but that was actually, that did not start with nonce 1, but the contract creation was then always 0. And this leads to a specific kind of account which was only possible to create before Spurious Dragon. This is an account where the code is empty, you have 0 nonce, but the storage is non-empty, and this leads to problems when you check for contract collisions. Because EIP 784, which defines how you check for contract collisions, that says, okay, you should check the nonce and the code, and that should be 0 and it should be empty, so that does not check for the empty storage. And this is what was introduced by 7610, because this was not specified in the protocol yet. But this condition is theoretically possible. At Spurious Dragon, we introduced EIP 161. This is the state clearing EIP. And this bumps the standard conflict nonce to 1 to mark these accounts. 224 of these accounts existed at Spurious Dragon, and 28 accounts of them exist today, which I will call the fossil accounts. The ones which were removed, so the difference of this 224 and the 28, These, it's actually no balance, and these are then empty by the definition of EIP 161, and these were then deleted from state already. So about EIP 7610, the arguments against this is that the address collision cannot happen in practice because this would, well, you need to do some, well, it's a theoretical attack. And there's also like this extra runtime code because you have an empty storage root check on creation, which might need an extra disk lookup regarding on the database layout, or you can check against a hard-coded list of existing accounts, which Gev has currently moved to. It's this PR to Gev, which is already merged. So there's now not the storage root check anymore, but the list check. And this list, I've checked it. I've also checked this against the list which I got at this EIP, and it's the same list. So that's good. Okay, so about this EIP, it's this pull request, which I will share here in the chat, because it's this one. Okay, yes. It's this PR, which I dumped in the chat. Okay, so at the fork block, what we do is we bump the nonce of all the accounts which have 0 nonce, no code, and non-empty storage. So there is at least one key with a non-zero value which exists in the storage sphere of this account. And the balance is non-zero because of this argument which I just made, because all the empty accounts have been cleared by this EIP 7523. The nonce is bumped before running the system contracts. So yeah, also before any transactions. The nonce bump is reflected in the block access list. There are thus 28 nonce bumps, and this converts the pre-spurious Dragon accounts, the fossil accounts, to accounts which can also be created now because this has no code, but they write the storage in the init code, and per EIP 161, the nonce of this created account is at least 1. So why should we do this? This makes EIP 7610 obsolete, because the EIP 684 collision check is not sufficient, because it is not possible to create these accounts anymore, where we have like this weird situation where we have storage, but we also have 0 nodes, which was this point. It removes the pre-spurious Dragon type of accounts from state, which is not possible to create anymore. It removes specific code at clients to handle these accounts. It removes also this type of accounts from state, so you can maybe do some kind of nice database layout optimizations. And it removes this, well, the special handling of these accounts, also in the testing suite. And the best point I want to raise is this simplifies the protocol, and it makes us all happy. Okay, that was my point.
Great. Thank you very much. Peter, I know you have a comment to make, but we have 2 more things to get through. Light client, just real quick. Do you feel like 5 minutes is enough or 4 minutes is enough to give an AA update, or do you want to kick it to the next one? Because if you want to kick to the next one, we can do some questions on Joachim's presentation.
I can go very quickly.
Okay. Real quick though, Joachim, if anybody wants to discuss this, where's the right place to go?
Let's do execution dev at R&D.
Okay.
Yeah.
Thank you. Matt, the mic is yours.
Thanks. Yeah, so I had a chance to talk to a lot of you guys in Svalbard last week. We had one major session where we discussed some high-level AA goals and constraints. This was kind of separate of how do we achieve these things, and was more focused on like what exactly are we trying to achieve. Posted the HackMD with the result of that session in the chat, and from there had a lot of other conversations with people more focused on the frame transaction proposal, and we are still working on figuring out what the right spec is that can make everybody happy. One specific spec item we spent a lot of time talking about was the 2D nonces, and we ended up deciding that we would just propose the 2D nonce mechanism for frame transactions as a separate EAP for now, and see if what the feasibility of actually including this together with the frame transaction in Hagoto would be. But yeah, I'm happy to answer any questions here offline. But otherwise, we'll just keep working on the spec for the next week or so, and then hopefully get to implementing some prototypes.
Thanks for the update. Mercy, do you want to go over your engine API v2 schema fix? Mercy here.
No, I just wanted to bring it up so that Codex can make a decision on it and also approve the PR. And also on this one, we'll be removing this so that people are aware of this. This PR 788. Thank you.
Great, thank you. That is all of the items on the agenda. Thank you guys for coming. See you in 2 weeks.
Thanks.
Bye bye. Thank you.
Bye.